signature feel to it.
Yeah, it's got an almost improvisational tone.
This semester on Stat 201, prepare yourself for YouTube, because we're all zoomed out. Cahoots and special guests, Tiny Brian, Puppet Shark, Evil Moobot,
I am Moobot.
Morty the Rabbit, and more. Super Statistics Bros.
Hey everyone, it is time for the last online office hours. We still have one tomorrow. But we are going to do some of the quiz. There's not that many quiz questions, so maybe even do the full thing. Maybe just start from the beginning, a very good place to start. So let's do this. A certain war story. We've done these ones before. We've been here before, have we not? We'll chill music right here in the background. We got Darius. Histograms were skewed. May you show them in your office hours? I was just working on my data and my histograms were skewed. Oh man. Yeah, what do you want to show, Darius? Do you want me to? What do you want to show about the histograms being skewed? Darius, good to see you here. Histograms were skewed, right or left skew. Monster Man, right to the high, left to the low. Yeah, you want to show me them during office hours like you want to in person, I think? Yeah, definitely. Darius, so good to see you here. Thank you, Darius. It really is a nice day today. For views and reach, right skewed. Yeah. You want to show them in person? Yeah, that's what I thought. I was like trying to figure it out. I want to see those. Let's do this right here. Okay, let's throw some Ubot points. Let's do this first question. If you have questions, ask them. I guess we'll do some homework. Why not? Stat 201, Chapter 19 quiz. A certain war story. Certain story describes. Let's do this. Okay, I think I've clicked the wrong button here, but that's all right. It's all right. And we have the null hypothesis is the first thing we have to figure out for the chi-squared test of independence. And the null hypothesis is always that things are independent, and the alternative is that they are not independent. Took a lot of great notes today. If you look back at our notes right here, where we talked about how to write the null, how to write the alternative. So when writing the alternative, you can use words like they're not independent, they are associated, they are dependent. So like prostate cancer and fish consumption are associated is a way to write the alternative. When you write the null, you just literally put the word independent between them because this is the chi-squared test of independence. There's no notation on it. We don't do mu or p. You just write that they're independent as the null, so pretty easy. Now, here's where people get stuck is on the test, you'll have to write out the null or things like that towards the end, like I reject the null that. So when you interpret these results, you have to know that this and this are independent as the null. It means they aren't related. So it wouldn't matter where you got hit, as The Rock would say. That's not The Rock. That was, wow. As The Rock would say, it doesn't matter where you get hit on your body. It wouldn't matter. The fatality of it, is independent. So the same percent of people get hit in the body versus the head of the neck or the limb. You don't want to really get hit anywhere. But if I'm going to choose to get hit, it's going to be on my pinky right here. I say, okay, I kind of chose that. I chose that with this finger. Smash two weights together. Not a good idea. There'd be no relationship according to the null, but we're looking for evidence of a relationship where we might see differing amounts. So the first thing we have to figure out is the expected values. Let's do this in jump right here. We're going to click on the table. You can see right here that limb had a lot more not fatal, where head and neck, only one person survived. Very high percentage of more fatality right there. Brando, good to see you. And body also high, but not as quite high as head neck injury site. Do not get injured anywhere. We're going to copy this table right here with copy to clipboard. We're going to hit Command-C or Control-C, Mac versus PC. Command-C on a Mac, Control-C on a PC. And then we're going to go over here to jump. And inside of jump, we're going to go right here. We're going to go to File, New, Data Table. Sure. File, New, Data Table. Also Control-N will do it, or Command-N. You're going to go to Edit, Paste with column names. Make sure it's with the column names because there are column names. If you do it wrong, it's going to look like this and it won't work. So make sure you paste with column names, make a new data sheet if you did it wrong. So now we're going to go and do the following. Tables stack. Tables stack. double click the two blue columns, and you should see this right here. Go ahead and click OK. Now, what I'm about to do is optional. I'm going to change this to site of injury by double clicking it and typing in site and hitting enter, enter. I'm going to change this to outcome by double clicking it and typing outcome and hitting enter, enter. There's the frequency of the data. We can see where someone was injured in the outcome, and you don't have to change those. It's just going to make it a little pretty right here. Now we're going to go to analyze fit y by x. We're going to say, does the site of the injury explain why there is a certain outcome? Just look at it. Does the site of the injury explain why there is a certain outcome? So maybe. And you have to put the data. I'll pause right here. If it doesn't look like this, you're going to have a bad time. Does the site of the injury explain why the outcome occurs? And here's the data with the counts of the observations. Let's go ahead and click OK. If the bars are perfectly even, Brando checking out those points. Here's 5,000 more for you, Brando. Ooh, you might get up there, hang around, ask some questions. If it's perfectly flat, you probably did it wrong because this one has a relationship here where you can see 98% of head and neck injuries were lethal versus the limb injuries, only 35% were lethal. We're going to change the table right here to only show the counts and the expecteds. And the expecteds, we want to show the math for this. Let's show the math. You can have officers during some. We'll do some. Probably not in person. Maybe just online. Nancy, good question. Thank you, Nancy. 5,000 points, Nancy. Really good question. We'll do some online office hours. We're having a big Kahoot on Friday. I'll send info about that. How do we get this number right here of 10 point? Let me pick this one. How do we get this 7.75 right there? So that is the expected cell count for this. What is the mathematics? Who knows the mathematics, which is row total times column total over grand total. So what do? This is practice from today. What do? Can't find a color I like. You gotta make the crosshair in on it. You gotta do the crosshair technique. So you gotta do that. Ooh, sure, why not? We're running out of viewable colors. Oh, I didn't mark it over there. It's the grand total. That's column total. So it's 37 times 31 over 148. And you simply just solve out the math right here. 37 times 31 divided by 148. There it is right here. There's the math. That's the expected count. Row total times column total over grand total. Make sure to know that math. You do get the formula sheet. We are going to format this. This was a right click on the table and format. And then under format, just to help us, we're going to go to fixed decimal down to 2. And now we get, we need to do it for that value. Really? Let's remove the counts and format the table again. Now we can do it. Fixed decimal down to 2 because it only wants the expecteds. So the question only says to put in the expected values, and you can see they are right there. Body, head, neck, limb, fatal, not fatal. So I'm just going to put it over here so I can look at it and copy the numbers. You can find these all by hand by doing row total times column total over grand total. You should try to do a few to make sure you know how to do it. Now it alt tabs over. Sure. It looks like I'll be throwing a first pitch out for the Smokies. There might be some other, I don't want to say other people will be doing it yet, but I've heard some names tossed around of some really awesome professors here at UT. So check out the Smokies next week, Tuesday through Thursday. Smokies doing $10 UT student tickets. So you can go to the UT, you can go to the Smokies game for $10. And if you're over 21 on Thursday, it is the Thirsty Thursday night. So drink responsibly, but half price drinks apparently. But shout outs to Smokies right there. And the Smoky mascots were in the library and they're out walking around. Fun stuff. Check out the new Smokies, new stadium. So the chi-squared right here is the sum of all the cell chi-squares. I know, woohoo, $10 ticket. Pretty nice time, right? The cell chi-squareds are found by the following. Just tell me, what is the difference between 1 and 10? I gave it away. What is the difference between 1 and 10? Who knows the difference between 1 and 10? Who knows the difference between, I'm calling it 10. For all intents and purposes, it's 10. So if you look at this right here, if you go here, 1 minus 10, square that over 10, you would get 81, 9 squared over 10, which is 81 over 10. And this is the observed minus the expected squared over the expected. and that is equal to a cell chi-squared. The observed being this value right here, the value you see, and so that's the observed. The expected being the value we'd expect by random chance, given the null is true, which is what we calculated earlier from row total times column total over grand total. And then you just solve out, square the difference. So we should get about 8.1, or it's actually going to be a little bit smaller. It's going to be about like 8. It's going to be about 8.1, very close to it. Let's find out what the answer is. The cell chi-squared for that one is 8.15. Once again, it's just carrying decimals that we didn't carry. And you do it for all of these. After you get, there's a really good test question. Teaching the test moment. After you get all the cell chi-squareds, how do you get the Pearson chi-squared test statistic? How do you get, which is the answer to that, how do you get the Pearson chi-squared test statistic? You take all the cell chi-squareds and what? Add them up. Darius on fire right there. You sum up all the cell chi-squareds. So the sum of all the cell chi-squareds, which we were just looking at, if you sum them all up, you get the Pearson chi-squared test statistic. So there's all the cell chi-squareds, you sum them up. So if you add up all these values right here, you will get 58.40, 58.38. I don't know. 58.38. If I make a typo, please let me know. How many degrees of freedom does it have? And shout outs to Daryl. The degrees of freedom are rows minus 1 times columns minus 1. Look at this, and you say, Brian, that's a 3 by 2. And then you connect your fingers right here, and you get 2 times 1. So you see here the 2 times 1. I think that works better. So it's a 3 by 2. Connect your fingers. 2 times 1. I like it, right? What do people think? Because I used to say drop your fingers and multiply, because it's a 3 by 2, and then you drop and multiply. But if you just bring it in, you can see the multiply right there. 2 times 1. So the answer is 2 degrees of freedom. Another way to think about it visually is if you're deleting one row, one column, do not use the totals. If you're deleting one row and one column, you delete this and you delete this. Do not use the totals. The totals are not part of it. The degrees of freedom are going to be the 2 degrees of freedom right there. It tells you the shape of the chi-squared you're using. There are 2 degrees of freedom. Now, classically, p-value is basically 0. Classically, what you have to do is you have to go to the chi-squared applet. So if you don't have the answer via jump, you have to go to a chi-squared applet. Darius. 5,000 voice Darius. I really appreciate that. I could go the whole office hours with no one here to tell me that. And I'd be like, someone would be like, there was an echo the whole time. I'm like, I'm sorry. So we put in 2 degrees of freedom to change the shape of the chi-squared. We find the p-value using the chi-squared. We put in 58.38, and it's, or whatever it was, it's ridiculously tiny. It's got 12 zeros. It's 0.0000000000000. So we definitely what? The p-value is ridiculously low. The p-value is basically 0. It's also in the jump output. I just know the chi-squared that large. There it is. That's basically 0. You can't see it. So we what now? Since the p-value is so low, we what? Since the p-value is so low, we what? When the p-value is low, reject the null. And we do have evidence for an alternative, so we conclude that there's evidence that they are not independent, which is the alternative. They're associated. Good stuff. I thought I would get one wrong. I'm going to make a typo here. This is basically the same as that question. Reject the bull. Do that. Reject the bull. This is the same. The null is bull. That's what's true right there. This is the same question. We might return back to it. It's literally the same. It's a 3 by 3. Let's do it. I'll just do it. It's the same question. Does anyone have another one they want to do, like the political one? Oh, no. This is the same question. We can probably do it a little bit quicker, but it's same thing. Tomato, tomato. Chapter 19 quiz. A certain story. Another certain story one. So once again, the null and alternative. When you write the null, you just put independent between them. The weapon used and the injury site are independent. That's the null. The alternative is that they're not independent. They're somehow associated. So now we go and we grab the data. And who can figure out, just do this for me real quick, the expected cell count for limb hit by arrow. So I'm asking for limb hit by arrow. What is the expected cell count for? This is a good thing to see if you can do it for the test. How many people would be expected to be hit in the limb by an arrow? I'm trying to do it in my head here, so I got to do it in my head while you do it. Ooh, it's going to be pretty small. It's going to be a little bit bigger than 2, I think. See if you can get it. 286. Oh, I'm not gonna. Don't let me get all the decimals before you figure it out. It's like 2.14 or something. No, wait. Oh, it's really close to that. Oh, it's like 2.11, I think. What is it? I say 2.108. What is it? So we're looking for, I'm asking for this one right here. Limb hit by arrow. So you have to take row total times column total over grand total. Yeah, and then use jump to do it. So there's the formula right there. You have to take that. I say 2.108. Oh, 2.118. I was trying to do it in my head. I got the 2.1. Okay, so I'm gonna stop carrying decimals. 2.118. Once again, the easier way to do this rather than doing them all, because you'd have to do this, you'd have to go over here, you have to drop this in, round to 2 decimals, like that. The easier way to get all the answers is to go here, copy to clipboard, and then copy the work, copy. You can do them all individually. Mm-hmm. Does that make sense, Darius? Like when you see it, like you can go through here, and because you have to do this by hand on the test, it's not hard to do. This is going to find the expected cell count for what? Doing 61 times 11 divided by 135 is the expected cell count for what? You just crosshair it in. Where does it match? Like, so that's the expected cell count for what? Like, you should know this, which is going to be like 5 something. I don't know, 4.8. That's the expected cell count for what? We'll draw it on here once you do it. That is the expected cell count for what? That math right there is the expected cell count for what? How many people we expect to be hit where with a what? It's that one. So that means how many we would expect. Now we saw 4 people. All these values inside of here right now are called the observed. Everything inside of there is the observed. And we are calculating the expected with the formula row total times column total equal over grand total. Row total times column total over grand total equals expected cell count. Right there. 4.97. Nice job, Darius. Yep. I was just taking guesses at it. And so you can do it all really quickly by going to jump, copy to clipboard, and then hit Command-C or Control-C. And then you go back here into jump. You go to File, New, Data Table. And then you go Edit Paste with Column Names. With Edit Paste with Column Names, you're going to need to go to Tables, Stack. With Tables, Stack, you're going to stack Body, Head, Neck, and Limb, and then click OK. And with this right here, you're then going to go to Analyze Fit Y by X. And let's go here and double-click and call this Weapon. And then double-click this, call it Site. Hit Enter, Enter. And now I think we want to see Analyze Fit Y by X. If you reverse them, it doesn't matter too much. Rock knows. It doesn't matter. Analyze Fit Y by X. Does the weapon explain where you got injured? And make sure to put data in here. We can reverse it. Let's see if the table comes out correctly. Here we go. Let's click OK. And we see arrow, ground, rock, sword. And arrow, ground, rock, limb. Oh, you see, it puts limb. It's because it got a typo. They made a mistake. And we can get all these expected cell counts by simply removing everything but the expected cell counts by de-checking everything, de-clicking, and leaving it only expecteds. Right-click on the table, go to Format, and change to Fixed Decimal, and add in 2 decimals, and click OK. Now you just copy the numbers. Look, we already have the 2.12. We found that by hand. And the one Darius found, 4.97, confirming the answer. Know how to find those by hand. Very important. Know how to find cell chi-squareds by hand. Observe minus expected squared over expected. Quantity squared. Be careful. Sometimes people just observe minus expected squared. It's observe minus expected quantity squared. 4.27. Oh, wow. There we go. We got all the numbers entered in just from the expecteds. Make sure to deselect. Next, we get down. They're probably going to ask us the chi-squared test statistic. Notice this chi-squared is smaller, leading to a larger p-value. It's when you have a smaller chi-squared, it's going to cover less of the curve. So you notice I'm decreasing the chi-squared. The p-value is going up. So bigger chi-squareds lead to lower p-values. because they're further out on the curve, and smaller chi-squareds lead to higher p-values. We have a chi-squared with how many degrees of freedom? Who wants to tell me? You don't cheat. It was there for a second. How many degrees of freedom do we have? You can do the trick. You can do the trick. If you know, you know. How many degrees of freedom do we have? How many degrees of freedom do we have? Brian, this is a 3 by 3. The degrees of freedom formula is rows minus 1 times columns minus 1. Rows minus 1 times columns minus 1. Rows minus 1 times columns minus 1. So what's the degrees of freedom? There's 3 rows. There's 3 columns. Rows, columns, minus 1, multiply. There are 4 degrees of freedom. Rotowave bomb. You know what? People are really needing these points. Rotowave with a Rotowave bomb for the end of the semester. Rotowave, love seeing you around campus and everything. 50,000 points Rotowave bomb right there. If anyone's talking, you've been talking lately, you might get those points from Rotowave. Class was really sad today, Rotowave. I think you're like, I'm sad to see class down one ended too. And Rotowave, I'm so glad. Remember, Brando and Darius, you can swing by any live stream. You can Rotowave bomb yourself. I know 50K. You need to show them your points, Rotowave. You need to. I know, but I'm proud of you, man. You need to show them your points. You'd be like, you need to flex those points. I'm telling you to do it. Just because I say. Like, you think you got points? Rotowave's got. Last time I checked, Rotowave got points. So you see right there, at the Thanos, Mando, Brian, Goku tier right there. Over 9,001. Just, yeah, I love it. Nice job with 47 hours. Great job right there. With over a billion points or so. No one's going to keep up with you, Rotowave. So we got the chi-squared. We have a little fun here to end class. The chi-squared right there is simply the chi-squared value. And the chi-squared right there is the Pearson chi-squared, the sum of all the cell chi-squareds. So if you go here and get your cell chi-squareds, and if you sum them up yourself, you'll get 7.16. 7.16 can be found by summing up the cell chi-squareds. Very important to know this. The Pearson chi-squared is the sum of all the cell chi-squareds. How many degrees of freedom? 4. Because it has 3 rows, 3 columns, 2 times 2, 2 degrees, 4 degrees of freedom. The p-value we can find manually if we take this and we go over here to the applet and we find the p-value. We need to enter in 4 degrees of freedom, the chi-squared, and there's the p-value of 0.128, which tells us what we saw was pretty likely by random chance given the null is true. It does say the 3 decimals. That same p-value is also in the output right down at the bottom. The Pearson has your p-value. The Pearson, not the likelihood. That's a different test. Since we're using an alpha of 0.05, which is the classic alpha, do we reject or not reject the null? This is a classic 0.05 alpha. When the p-value is low, reject the null. When the p-value is high, just let it fly. Lower than alpha. So reject, not reject. What do you say? These Panera chips are tempting me. Behind me. What do we do here? Reject the null, not reject the null. When the p-value is low, reject the null. When the p-value is high, just let it fly. So what do we do? What do we do? What do we do? If the p-value is low, you reject the null. Low means lower than alpha. If the p-value is lower than alpha, reject the null. If the p-value is high, just let it fly, the null. When the p-value is low, reject the null. When the p-value is high, just let it fly. I say it a bunch of times, someone will hear it in their head in the back. P-value is low, reject the null. P-value is high, just let it fly. Well, by let it fly, we mean not reject, fail to reject. Same thing. Tomato, tomato.
It doesn't matter.
And this means we do not have evidence to the alternative that they are not independent. Because we're talking about the alternative. We do not have evidence to the alternative they're not independent. Really? Uh-oh. What did I do? What did I do? We do not conclude that they are not independent. Okay, that's right. Is it really one of these up here? Oh, no, no, no. Someone say it. I said this right. Catch it for 5,000 points. Someone should have called me out on this. This is called the what test, and do you see it? I see it now. It's on this screen. This is where the arrow's at. It's not down there. The arrow's up here. If I was a student, I'd be like, no, I know this. He said it like so many times. He keeps saying the null, blah, blah, blah. In the chi-squared test, the null is where we say the what's or what. In the chi-squared test, we say they're independent. We did this a lot during class. We say they're independent, so I reversed it. I don't even know what I did. I wonder, I'm going to do a quick check on the video. I want to see this. I want to go rewind the video. Okay. So there we go. I got the video pause. I want to see if I had that misclick. Did I click back? Sometimes I click back to the screen. No, it's wrong there. That's not one. Still wrong. Look. I got it right. There it is. Okay, when I click back to the screen, this is when I do it. That was it. Wow. Did anyone see that? Watch this. I click onto the screen, and that's where it changed right there. That's when it changed. So I was like, why would I select that? Am I going crazy? I marked that one. Misclick. Suppose we conclude a test and end up rejecting the null. Which of the following is appropriate? Well, then, what it would do. Stat 1, Chapter 19 quiz. Suppose we conduct a test. Oh my gosh. Well, this means we found evidence for the alternative. The two variables are definitely not independent. The way they phrase this, it's better to say they're associated. Don't like that this also is an answer, but usually we just say there's an association. That's a really classical way of stating when you reject the null, to say that the two variables have some relationship, that somehow, you look at the notes right here, classically, your status or your survival of the Titanic was related to your class. People who were in first class were more likely to survive versus people. Awesome, Darius. See you later today. And thank you again. 5,000 points. I'll get questions right. I promise. I'm trying. Here we got the preterm one. Let's see if we do a few more of these. Democrat, Republican, Independent. Do like two more. We've done that one. Okay, so there's only really two more big ones. Okay, we can probably do them all really quickly here. Then we'll have every question in the video. Well, what does it matter?
It doesn't matter!
Okay, so this one is at the 28:32. And thank you, Darius, for helping your friend, I think, study. You're saying it's really awesome right there. Chapter 19 quiz. Okay, most pregnancies are full term. Okay, most pregnancies are full term. We're looking at the outcome of pregnancy, whether it was late or early. They should just say on time or early or something like that. And with this right here, the null hypothesis would be that the two things are independent. How old someone is, if you're 20s, 30s, 40s, whatever you are, the outcome of your pregnancy is independent of your age group. So all we have to do is look for independent, but we should also know how to write it, that the two things are independent. It'd be really hard to guess everything, but we should know that if the chi-squared is high, the p-value is going to be lower, or if the chi-squared is low, the p-value is going to be higher. It's not too hard of a test to run. We've done a lot of these step by step, and they asked us for the expecteds earlier, but we can just run this test pretty quickly. Here's how to run the test. Go to copy to clipboard, and then hit Control-C or Command-C. Bring up a new data table in Jump with File, New Data Table. File, New Data Table. With File, New Data Table, we're going to go to Edit, Paste with Column Names, Edit, Paste with Column Names, and then go to Tables and Stack. In Tables Stack, we're going to double-click both blue columns, only the blue columns, and then click OK. OK. Now you're going to go over here, and you could double-click this. This is optional, and type age group. Hit Enter, Enter. This is outcome of the pregnancy. Enter, Enter. And then we go to Analyze Fit Y by X. Analyze Fit Y by X. It has to be red, red, blue. If it's not that way, you're going to have a problem. Analyze Fit Y by X. We're going to put, does the outcome or does the age group explain why there is an outcome, and put the data down here. I'll pause. This way your screen should look. Does age group explain why there is a certain outcome? And the answer is nope, not really. If you notice, there's a little bit more early in the over 40 group. Not a big difference, because we get a chi-squared of 5.26 and a p-value of 154. 5.26. Oh, there's another decimal. I didn't. 1.54. Another decimal. I didn't look at it. think it rounded up. So 2.5, 5.254 or something. 256. That's right? And as long as I haven't made a typo on the numbers, I should double check them, but what's the fun of that? So since the p-value is way higher than alpha, I do not reject the null. I do not find evidence for alternative. My p-value is way above alpha. So the p-value is way greater than alpha. There's not evidence to reject the null. There we go. Just think when the p-value is high, you let the null fly. So since the p-value is way above alpha, alpha being 0.01, which is the threshold of significance they're using, that's the rejection criteria. And here, let's go to the next one. This is the last real question on here, and it's very similar. It's a nice and easy one. Oh, okay, get a good stretch in. Oh, yeah. Go on one more quick walk after this. Walks really help me. You got to stretch. You can't sit for too long. Your body needs it. Okay, so the null hypothesis is chi-squared test. Oh, gotta mark the question. Come on, Brian. What you doing with life? Stat 201, chapter 19 quiz. A poll investigated. Okay, null hypothesis. Somebody's political affiliation is independent of where they were born. So that's all we do. So political affiliation is independent of region. It's not independent. Let's bring the data over to Jump right here by going to the box, going to copy to clipboard, hitting Command-C or Control-C, Mac versus PC, and then going to Jump and go to File, New Data Table. I said File, New Data Table. Inside of File, New Data Table, we're going to go to Edit, Paste with column names. Very important. Don't forget to do with column names. And then we are going to go to Tables and then Stack and then double-click the blue columns. Double-click, double-click, double-click. Now we go back by hitting OK, and then we change this to region if you want. This is optional by double-clicking, hitting Enter, Enter. Label, let's say Party. And then we hit Enter, Enter. And we have our data ready. That was optional. You can double click it and then change it. It just makes the data look more pretty. Go to Analyze right here. Under Analyze, we're going to go to Analyze Fit Y by X. With Analyze Fit Y by X, we're going to say, does somebody's region explain why they are a certain party? Do not forget to put the data into frequency or you're going to have a bad time. So does someone's region explain why they are a certain party? The answer is, not really. According to this data, maybe in reality. We see right here that it has with it 4 degrees of freedom because this is a 3 by 3. Multiply together 2 times 2 because you delete one row, delete one column to get the degrees of freedom. That tells us the shape of the chi-squared. If we had to graph it, it's very important. The chi-squared test statistic is 2.714 found because the Pearson has your chi-squared, also has your p-value, and those are the answers. So all we do is just take the Pearson chi-squared test statistic. Oh, I almost accidentally clicked a right answer. We will not reject the null. The Pearson is 2.714. I'll show these answers once I put them in. The p-value is 0.4 decimals. We got it. So there it is right there. And the there's the chi-squared down below, the chi-squared test statistic, the Pearson. And we fail to reject the null because it's way higher than a classic 0.05 alpha. We do not have evidence that they are not independent. So that should do it. And then the last questions on here for all the chi-squared procedure, the sample size condition is checked by the expected cell count frequency. This is a t-test. We're not doing t-test. This is the proportion test. We're not doing proportions. That is the chi-squared cell counts greater than 5, at least 5 expected cell counts. The degrees of freedom for a chi-squared are rows minus 1 times columns minus 1, which is based on the dimensions of the table. And you see it right here classically in the notes somewhere. Where's it at? Rows minus 1 times columns minus 1 is the degrees of freedom for the chi-squared, telling us the shape of the chi-squared. And that's got it. Well, we're going to take a quick walk. We're going to do some in-person office hours. Until then, bye for now, everyone. Bye!